Okay, our first unit in geometry this year is logic, and we'll start with this first step in just recognizing patterns and what comes next. So if you look at our first pattern, we have circle segmented into 4 quadrants and a dot in it. Think about what you would consider as the next value in that pattern. Same thing over here. Mathematically, we can take squares and we can go ahead and evaluate all of these and we'll end up getting a pattern. Same thing with this example. Go ahead and pause your video and take a look at the patterns. So as we look at our patterns, we can figure out that the next thing here should be a circle, and we'll have that dot there. This one, we have a pattern where we have what looks to be a square, and our 2 dots are up here. As we go through our algebra here, we've got 9 squared is 81. And I'm going to just show the pattern here, and you can kind of see what comes next. So you see we're adding an extra 9, we're adding an extra 0 in there as we continue to go along. When we have our 1, 2, 3, 4, 5 times 9, we get this. And so on and so forth. When we get to our third example, though, we have 2, 4. Can you think of some possibilities there? Some of us might say, yep, 6, 8, 10. Some of us might say, well, this is squaring, so it's 2 times 2, which is 4, 4 times 4, which is 16, and so on and so forth from there. There's a couple of different patterns here, so how do we know, and are there possibilities? We use patterns to identify what will come next. That's using inductive reasoning. You look for a pattern and then apply a rule to the pattern. Here are some examples of conjectures that are using inductive reasoning, and we'll talk a little bit about what a conjecture is. It is an unproven statement based on our observations. So it's just something that we've recognized, and now we're trying to see if there's a pattern. So all ice I have ever observed is cold, therefore all ice is cold. I have an observation, and I'm making an assumption based on the pattern I see. The sun has also risen every day of my life, therefore it will rise tomorrow. I have always gotten an A in math class, therefore I will always get an A in this math class. We recognize a pattern, we make an assumption. All members of the same sample got well from a medication, therefore the entire population will get well from this medication. So you come up with your own conjecture. There are some pitfalls, some negatives, some takeaways from inductive reasoning. So if I say that all the animals I have seen have tails and are horses, if I then look somewhere else and say, oh, that animal over there has a tail, therefore it has to be a horse. We've concluded that all animals have tails, have to be horses. But is that true? Can you think of a counter example? Can you think of something that doesn't fit this pattern? I'm sure you can. I can think of a dog that has a tail, a cat that has a tail. They're not horses, but they are animals with tails. So you have to be careful about using inductive reasoning for everything. Unless you can account for every case, you can never be really sure if this conjecture, this observation from a pattern is true using inductive reasoning. So what's the point of even knowing what inductive reasoning is? We can come up with a counterexample, and so that will definitely disprove that conjecture. All the animals I've seen have tails and all are horses. That animal has a tail, therefore it's a horse. We have here a cat has a tail. but it's not a horse. So we've just found a counterexample, and that says, okay, this conjecture is false. Can you come up with other counterexamples? I'm sure you can come up with a ton. So now we're going to go ahead and disprove the conjectures by finding a counterexample. So we have all odd numbers are prime. So we have to know what odd numbers are. We have to know what prime numbers are. So I'd like you to think about coming up with a counterexample to that conjecture. Odd numbers: 1, 3, 5, 7, 9, 11, 13. Is there one there that I've mentioned that isn't prime? Number 9 should have popped into your brain there. Number 9, the value 9 is an odd number, but it is not prime. Prime meaning that I can only create that number by multiplying 1 and itself. So here I can multiply 1 times 9, but I can also do 3 times 3. The difference of two positive numbers is always a positive. Can you think of a counterexample to disprove that? So just to review some vocabulary that we've been using, a conjecture is an unproven statement that is based on an observation. Inductive reasoning is when you find a pattern in a specific case and draw a conclusion for that. When I'm using inductive reasoning, I want to think about a counterexample. Is there a counterexample? It's a specific case for which my conjecture is false. Those are the important vocabulary key terms for our first unit on logic. You're in a car along a highway and see this billboard. Every great American city has at least one college. Worcester has 10. What is this ad trying to suggest? Is it supplying enough evidence? So you might take a look at that and think, oh, okay, well, every great American city has at least one college. Worcester has 10. Therefore, Worcester has to be the greatest because it has more than one. Does the ad supply enough evidence to that fact? Worcester is a great city, but no, we only know great cities have a college, but we don't know if having a college means it's a great city. We know that there are great cities and they have colleges. That's amazing. But does having a college make you a great city? So that's kind of an interesting ad. All right, you're going to try now. Analyze the following conjectures. Can they be disproved with counterexamples? Go ahead and pause the video and see if you can come up with some counterexamples to these statements.